This video is designed to show you how to get started on the ocean temperatures analysis. Directions. Use the ocean currents map that you colored to answer the following questions. You can also use Miss Barrett's map by clicking here. So I will click this link to open up a digital version of the colorful map. You want to know that the temperatures shown in this map are the mean or average sea surface ocean temperatures. Also, you want to remember that all of these temperatures are in degrees Celsius. Scientists use degrees Celsius to take their measurements, while in the United States, when we're typically talking about the weather or giving a weather report, we use degrees Fahrenheit. So here is an interesting question. How do scientists know the temperatures of the oceans around the world? We want to be mindful that the ocean covers 71% of the Earth's surface, and throughout the ocean water, there are temperature probes continually taking the temperature of the ocean water. A lot of military ships from different countries are taking the sea surface temperatures and they're feeding this data into computers and generating models of what the Earth's climate will look like years from now. And they're also giving us the average ocean temperatures that we are able to have on this map. And also, you want to know that the temperatures were taken not very far down into the ocean, only about a quarter of a mile. We do want to review what negative temperatures mean, so it is helpful to click here to watch a video explanation. We have negative temperatures in degrees Fahrenheit, which are very cold temperatures. There are also negative temperatures in degrees Celsius, and those are very cold as well. Since we use degrees Fahrenheit so often in our speaking about the weather, we're going to repeatedly take these temperatures that are given in degrees Celsius and we are going to convert those temperatures to degrees Fahrenheit. And we have several ways that we can do that. We could work through this math formula. We take the temperature in degrees Celsius, multiply by 1.8, and then add 32 to get the temperature in degrees Fahrenheit. So for example, if I wanted to know what 33 degrees Celsius is equivalent to in degrees Fahrenheit, I could multiply 33 by 1.8 and then add 32, and now I have a temperature in degrees Fahrenheit. Also, we can click here for a digital converter, and I can just put in 33, and then I have 91.4 degrees Fahrenheit, which is about 91 degrees Fahrenheit if we round to the nearest whole temperature. Also, Google has a nice temperature converter. You can find that by typing in Celsius to Fahrenheit conversion. That might get us to that. Possibly. Well, we have several. So there are several on here that we could use. So let's go back, and it says in degrees Fahrenheit, what is the lowest temperature shown on your map? So we should look to the north and south poles. The lowest temperature shown on the map would be -2 degrees Celsius. So the way negative temperatures work, the further away you get from zero, if you're a negative number, if you're a negative temperature, the colder that temperature is. So we will say -2 degrees Celsius. So we want to be careful. In degrees Celsius, the lowest temperature is -2 degrees Celsius. Now we are asked to provide degrees Fahrenheit. So I'm going to take my temperature converter and I will type in -2, and that is equivalent to 28.4 degrees Fahrenheit, and I'll round that to the nearest whole temperature, and so that would be 24, just going to double check, or no, that's 28, so that's 28 degrees Fahrenheit. There is a nice way that you can put the degrees Fahrenheit symbol on a Google Doc. You type in control period, or yes, so control period, and that puts your cursor up high. So you type in the little O, and then control period again, you type in capital F. So that is, you type in control period to get what we call a superscript, and then control period to get your regular cursor back. It's really, really, really important to label each of your numbers, because in science, we always label our numbers. And on this document, we are constantly giving temperatures in degrees Celsius or degrees Fahrenheit. So we have to be really clear what our label is. So the lowest temperature shown on this map is 28 degrees Fahrenheit. Now, our next question, in degrees Fahrenheit, what is the highest temperature shown on your map? Well, here's a hint. First, in degrees Celsius, the highest temperature shown on my map is, let's go over to the colorful map, and the highest temperature is 33 degrees Celsius. So I will type in, just to give or finish my hint, 33, and then control period, little O, control period, capital C. So that's degrees Celsius. I need to convert that to degrees Fahrenheit. 33 degrees Celsius can be rounded to 91 degrees Fahrenheit. 91, control period, to get my little O, and then control period to get my cursor back. So this is 91 degrees Fahrenheit. That's really warm ocean water. So if you think about this, we have quite the range, 28 degrees Fahrenheit to 91 degrees Fahrenheit. Remember that these are taken from average sea surface temperatures. You might be wondering about that 28 degrees Fahrenheit being the temperature of really cold liquid water, because water freezes at 32 degrees Fahrenheit. But something to know is salt water will freeze at a lower temperature. This is because when water is forming those ice crystals, the water molecules have to kick out the salt. The salt does not become part of the ice crystal structure. And so the water has to go down to a lower temperature in order to kick out the salt particles and form that crystal structure. So salty ocean water is going to freeze at a lower temperature, and this means that up at the poles, the South Pole or down at the South Pole or up at the North Pole, that water is going to feel really cold. If someone was to choose to go swimming in it, or they're on a ship and the ship capsizes, it could be very dangerous. So it's very cold by the poles. So now it says, try to find Long Island and New Jersey on the colored map. Click here for a map of the United States. What is the temperature off the water off of this coastline? Well, Long Island is part of New York, and New Jersey is a state. So let's click here to get a better look. And New Jersey is this yellow, kind of a zigzag state. Then you can find Long Island by looking for New York State and this little peninsula that juts out. It's almost like, looks like it might be a claw or part of like a hedge clipper. So that little peninsula, that is Long Island. And we're interested in the temperature of the ocean water that's in this little corner between Long Island and New Jersey. So we want to take a mental picture of what this looks like on the United States, and we can be mindful that it's just a bit down south from the Great Lakes. So if we go over here, this is Lake Michigan. Here we are in Illinois, just off of Lake Michigan. Chicago borders Lake Michigan, and Lisle, Naperville, Woodridge, those are western suburbs of Chicago. So we're right around here. And Long Island and New Jersey, part of this little corner that we're interested in is about even with part of the Great Lakes. So let's remember what that looks like and go to our colored map, our colorful map, and we'll expand the view. And then we want to take a look, and we see there's Florida. And if we travel up the eastern coastline, we don't want to go too far north. We want to make sure that we're just a little bit below the Great Lakes, which are over here. So that temperature is 21 degrees Celsius. So right over here, we would be on the border of Long Island and New Jersey, and that is 21 degrees Celsius. So we'll type in 21 degrees Celsius. And we'll highlight our answer so that it really stands out. So then we need to find this in degrees Fahrenheit. So let's go to our temperature converter, and 69.8 degrees Fahrenheit. So that's about 70 degrees Fahrenheit. So 70, and then control period, O, control period to get my cursor back. So that's 70 degrees Fahrenheit. And so then we do a similar procedure for number 4. We look for Texas, Louisiana, Mississippi, Alabama, and Florida on that map of the United States. And we're going to find the temperature of the body of water off of their combined coastlines. That body of water is called the Gulf of Mexico. So let's take a look at this map. And there's Florida, Alabama, Mississippi, Louisiana, Texas. These are considered Gulf states, and this body of water is the Gulf of Mexico. And so then we can go to this map and look for the Gulf of Mexico on this map. So we can always find Florida. We can find that by looking for Florida. And this is 27 degrees Celsius. So then we'll type in 27 degrees Celsius, and then I'll highlight that so that it really stands out. And we want to convert that to degrees Fahrenheit. So we'll type in 27, and that is, if we round that answer, that's about 81 degrees Fahrenheit. So 81 degrees Fahrenheit. And so then we want to know, what is the range of temperatures from off the coast of Long Island and New Jersey down to the Gulf of Mexico. So this means we give the high and the low, or the low to the high. The range is given from the lowest to the highest. So off of Long Island, New Jersey, we're at 70 degrees Fahrenheit. So I'll copy that 70 degrees Fahrenheit. All the way up to 81 degrees Fahrenheit. So this means that if you're looking at a map of the United States and you go from, and you're swimming along the coastline or you're in a boat, the average temperatures range from 70, so that was 70 degrees Fahrenheit, all the way to go around Florida, 81 degrees Fahrenheit. So 70 degree Fahrenheit water is pretty cool. That's colder water. It would not be that comfortable to swim in 70 degrees Fahrenheit water. 81 degrees Fahrenheit is very warm water. And we want to identify the ocean current that is running along the eastern coastline of the United States that is causing this temperature of ocean water. So it says, click on the image of major cold and warm global ocean currents. So this picture shows these major and regular global ocean currents. So by expanding the view, we can see that this red current number 6 is a warm current, and that is the current that is going around the Gulf of Mexico and up the eastern coastline of the United States. Notice that this current really originates from currents that came from the equator near the coast of Africa. This is very warm water, so currents number 8 and 9. Okay, so current number 8 is the north equatorial current. Current number 9 is the equatorial countercurrent. And these currents split, and one of the splits is the Gulf Stream. The Gulf Stream is a major and very important and regular warm ocean water current. And notice how that Gulf Stream veers across the Atlantic Ocean and is then called the North Atlantic Drift. So these currents get their names based on their proximity to different land masses or ocean waters. And when you're in the middle of the Atlantic Ocean, we would call this current the North Atlantic Drift, as it drifts off across the Atlantic up to Europe. Right around here, this is the United Kingdom. And these going up further north, these are the Nordic countries like Norway, Denmark, Sweden. So this current heads off towards Europe. But around the United States, it's the Gulf Stream. So this is the Gulf Stream. And this is a warm, very important that we write warm water current. So then you want to make sure you take time to watch the video about the Gulf Stream and then continue answering the rest of the questions using the procedure and the method that I have shown in answering these first several questions.